This lesson is on SOL 715, which is our inequalities. And if you remember, an inequality is literally what it sounds like. It's something that's not equal. It's our greater than, less than, greater than, or equal to, less than, or equal to, but not just a plain equals to sign. So a one-step inequality is defined as an inequality that requires the use of one operation to solve. So for an example, x minus 4 is greater than 9. Well, our job is still to solve for x, to figure out what type of answers could x be. Not what it's equal to, but what are some numbers that it could be. So to do that, we're still going to draw our line, and we're going to use an inverse operation. And so the inverse of subtraction, if you remember, is addition. So I'm going to add 4 to both sides. And I'm left with x is greater than 13. Do not mess up and say x is equal to 13 because it's not. This says that x is greater than 13, which means it needs to be a number like 14, 15, 16, 17, and so on. It has to be something greater than 13. Or let's look at the next one. 2n is less than or equal to negative 14. Well, to solve this one, we think about what it means when two things are touching. It means multiplying. So the opposite of multiplying is dividing. So I'm going to divide by 2. And I'm left with n is less than or equal to negative 7. So it could be other numbers. It could be any number less than negative 7. It could be negative 8, negative 9, negative 10. As long as it is less than negative 7 or equal to negative 7. Now, inverse operation, just a reminder, the inverse operation for addition is subtraction. And the inverse operation for multiplication is division. Now, our special rule, and this is one where you just need to pay close attention, when both expressions of an inequality are multiplied or divided by a negative number, the inequality symbol flips. So if it's a greater than, it's going to become a less than. A less than becomes a greater than. It literally flips. So we solve it the same way, though. We still draw our line at the symbol, and we still use an inverse operation. So the inverse of negative 3, x would be divided by negative 3. Now right here, we're dividing by negatives. And when you divide both sides by a negative, we have to flip our symbol. So x is no longer going to be less than, it's going to flip to a greater than. 15 divided by negative 3 would be negative 5. So x is greater than negative 5. Do not say equal to, it is greater than negative 5. Has to be like negative 4, negative 3, negative 2, 0, any positive number. So it says, use a number line to represent your inequality. If you remember, an open dot, which is just like a circle, means that the number is not included. Is not included in your answer. And we use it with the symbols greater than or less than, because it doesn't actually include whatever number. Like this up here, x is greater than negative 5. It didn't include the negative 5. It was any number greater than negative 5. When you're using the greater than or equal to or less than or equal to, we used a closed circle or a closed dot. So whenever you see these, you use that closed dot. So solving and graphing. Let's look at the first one. We're going to go ahead and solve for u first. So u plus 5 is greater than 7. We would do the inverse, so we would do minus 5 on both sides. Then we're going to get u is greater than 2. Well, I also need to be able to graph this. So I know I gave you lots of them. I'm just going to put some numbers that are around 2, maybe 0, 1, 2, and 3. My first job, I'm going to look at this symbol. Is this going to be an open or a closed dot? And think about it. U is greater than 2. It does not include the 2, so I'm just going to put an open dot. We could also look up here to remember open dot. And then what kind of numbers would be greater than 2? And if you remember, think about it. 3s, 4s, 5s, all the numbers that are this way on our number line. And a little hint that some of you used was if your variable was first, you could turn your symbol into an arrow and know which way it points. Now, if your number was first, it would go the opposite direction. But as long as your letter's first, your symbol points the same way that your arrow is going to point. I would like you to complete these on the bottom and get them checked before moving on to the problems on the back.